Hi everyone, in this video we're talking about further trig rules. So that's the sine rule and the cosine rule. Let's say we have a triangle that looks something like this, and we can label our triangle with A, B's and C's. The little letters, so little a, corresponds to angle big A. So if we have a look, the little letters represent the lengths of the sides, the big letters, or the capital letters, sorry, indicate the size of the angles. So here we're just labeling A, B and C. It's usually a little bit tricky to tell capital C from small c, so that's why it's really important that you remember what each letter represents. There we go, so here's our triangle A, B and C. Further trig rules apply when we do not have a right angled triangle. Okay, so in this case we don't have a right angled triangle. Let's see an example of how these work. Before we do that, let's write down our rules so we can remember them. So we'll use the same coloured pens here, may as well. The cosine rule states that c squared, little c squared, is equal to a squared plus b squared, take 2 times a times b times cos of capital C, which is our angle. Okay, so that's our cosine rule. And you can remember the cosine rule because it has cos in it. Okay, the other one that we need to remember is the sine rule. Now the sine rule states that A on sine A equals B on sine B equals C on sine C. So that's the sine rule. We can write the sine rule with the little letters on top and the signs on the bottom, or if we like, we can also save some time by writing sine A on A, sine B on B, sine C on C, and just flipping those. And it will depend on what you're trying to find as to which one will save you time to write down. But let's have a look at an example question of this. Let's say we have a triangle that isn't a right angled triangle, and for example, let's say we know some of the side lengths, or all of the side lengths in this case. Let's keep with the same colours, so we've got 5, 4 and 6. Okay, so let's say we know these sides and our question is to fill in the angles because we don't know the angles. Now there's a trick to know whether you should use the sine rule or the cosine rule. So you ask yourself, do you know a side and its opposite angle? If you do know one side and its opposite angle, then you use the sine rule. If you don't have a matching pair with this side and its opposite angle, then you'll have to use the cosine rule. So here, because we have no angles, we obviously don't have a pair with the side and its opposite angle. So that means we'll have to use the cosine rule. Now, our cosine rule we had up here. So let's just grab that. I'm just dragging that one down. Okay, so there's our cosine rule. So we're going to fill in the numbers now. We have 4 squared equals 5 squared plus 6 squared. Take 2 times 5 times 6 times cos of C. Here we go. So we've got 4 squared equals 5 squared plus 6 squared. Take 2 times 5 times 6 times cos of C. Now it's important to remember that when we're using the cosine rule, for example here, we're trying to find this angle C. It doesn't matter if we label the other angles A and B with, or our other sides A and B like this, or if we have them the other way around. Either way is fine. Okay, so this is what we're working with. What we're going to have to do is rearrange. The easiest way for us to do that is we'll pull the 4 squared across to the right, and we'll move this 2 times 5 times 6 times cos of C over to the left. So when we do that, our 2 times 5 times 6 cos of C becomes positive, and it's actually 60 cos of C. Then we have 5 squared is 25, plus 6 squared, which is 36. Take away 4 squared, which is 16. So we're now subtracting the 4 squared just because we've moved it across to the right. Okay, when we do that, we've got 60 cos of C. I'm sorry guys, I'm having so much trouble with this today. There we go. So 60 cos of C is equal to, when we do this 25 plus 36, take away 16, we get 45. So let's divide both sides by 60. Cos of C equals 45 divided by 60, which is equal to 0.75. So now we'll use inverse cos, or arc cos, to calculate what C is. So C has to be equal to inverse cos of 0.75. And when we plug that into our calculators, making sure we're in the degrees setting, we get that C is about 41.4 degrees. Okay, so if we have a look back to our diagram, that angle C there is about 41 degrees. Now, we want to fill in the remaining angles, so the next angle we'll look at is B. Okay, but you can choose either one, but let's choose B. Let's also fill in, we know what C is, so we may as well write it in, 41.4 degrees. Now remember, with our sine and cosine rule, do you know a side and its opposite angle? Well, here we do. Have a look at this. We've got this angle here, 41.4 degrees, and its side. So we know that side and opposite angle pair, which means we now can use the sine rule, which, in my opinion, is the easier one of the rules. So we'll use that. Now that we know the sine rule, we also need to remember whether we should put our sines on the top or on the bottom to make our calculations easier for us. Because we want to know the angle, it's best if we put our sines on top. So, sine of C on C is equal to, now for B we used green, so let's keep with that, sine of B on B. So because the angle side pair that we know is our C angle and our C side, we need to have that in our sine rule. The one that we're trying to find out is going to be the other one we use in our sine rule, and here we're trying to find out B. So we know that sine of 41.4 degrees divided by 4 equals to sine of B divided by our length B, which was 6. Let's multiply both sides by 6 so we can get sine of B on its own. So we have sine of 41.4 degrees divided by 4 times 6 is equal to sine of B. Okay, so when we do that calculation on the left here, we find that's about 0.99. So we know that sine of B is about 0.99. So now we'll use inverse sine to calculate what B is. B has to equal inverse sine of 0.99. And making sure our calculator is in the degrees setting, we plug that in and we find that B is approximately equal to 81.9 degrees. So let's go back and write that on our diagram as well. So instead of B, we know we have 81.9 degrees. Okay, so we've only got one angle left. We could keep using the sine and cosine rules, but we do know that angles in a triangle have to add to 180 degrees. So we know that angle A plus angle B plus angle C is 180 degrees, and we have two of those angles, so it's going to be really nice and easy for us to calculate angle A now. So we know A plus B plus C equals 180 degrees. We don't have angle A, so we've still got that on its own. A plus angle B we found was 81.9 degrees plus angle C, which we found was 41.4 degrees, equals 180 degrees. So let's just subtract angle B and angle C from 180 and we should get A. So A equals 180 degrees, take away 81.9 degrees, take away 41.4 degrees, and we find that angle A has to equal 56.7 degrees. Let's plug that back into our diagram. There we go. And we finished the question. So in this question, we had all of the side lengths and we were able to use the cosine rule, the sine rule, and then just the fact that our angles in our triangle add to 180 degrees to fill in the angles in this triangle.